So when we do our PV site assessment and we're all just learning about the assessment reports and going out to a location and doing a site assessment, there are some key parameters that we want to all adhere to. Now, I understand that they will change throughout time as variables change, pieces of equipment change, and other sorts of things. But here's some things that we have found, and I just was thinking of one as cutting this video. I'm going to add it to the very end here, but here's what I've got. Very first thing, when you do the site assessment, make sure that you do not infer any sort of code issues, safety requirements, structural damage, electrical changes, electrical inspections, that sort of stuff. Now, there's a few things that you're going to want to make sure about, and you can see me as I'm cutting this video. I'm going to correct this stuff, but what I want you to know about here is there's some variables that you're going to need to know here. So, simple video, real to the point, bam. Can't ask or say any of those things. You can suggest that there is a problem with the building. You can imply and say, I have noted that there's some electrical concerns, but you must include a suggestion or note that a professionally licensed person needs to investigate that. We do not and cannot, unless you are a licensed electrician, unless you're a structural engineer or a roofing person, we can't make any of those claims. However, we can state, and please observe those things, but we are simply making a report to determine whether the solar as a location is valid and the cost assessment of that process and project that we have. So here's some key ingredients. Section 1, make sure the math that the client wants from question 4 in section 1.0 is what you build the report on. Let's say the client, from their financial abilities and their solar resources, want to do a 50% offload of their electrical costs. Make sure when you get to the 6.2 and the 7s that talk about the financial incentives that they run to that 50% value. Don't say, hey, the customer wants 50%, and then you go off in left field and do a 5 kilowatt system that unloads all of their electricity needs. Don't do that. Please don't do that. So that's one item. In section 1.2, find what the most current electric rate is. Go to Ameren, go to Cornbelt, go to Commonwealth Edison. These are local power companies and electrical co-ops in Central Illinois. Go to that location, that electrical company's website. Find what the current rates are. That's one thing you need to be versed in. Another thing that you need to know is what is the liability insurance? What is the feed-in rates? What are any sort of other economic incentives or disincentives that company has for solar? We need to make sure that those are all in the report. Section 3, assumption. No need to have a placeholder for optional areas. So let's say in section 3 you find that there is a ground-based system. Well, just adjust that report to reflect only a section of a ground-based system. Don't include the roof-based system. So the generic template is there for us to document and put in, but really the point of it is to have a customly tailored project that the client can read and use. So don't leave things in that you don't need to be. In future sections, if there is any information that's not there, doesn't need to be there, remove it. If there is something that's not applicable, use your best assessment and judgment to determine whether it should stay in or go. When you use section 5.0, we like to use PV Watts, which is through the Department of Energy website. So it's an open source energy calculator. Here's the thing that you need to make sure of. We want to make sure that it is facing true south. Now, I understand that some of us in solar thermal systems will talk about using a financial calculator, and they will make south 0 degrees because everything needs to point south in order for it to work. For our report here and for PV Watts, make sure that the angle is 180 degrees. Base everything on the 0 degree of true north. On the derating factor, a good assumption to make is 80%, that 0.8. We're going to talk about that when we get there, but make it 0.8. When we get 6.2, the financial assessments that we calculate there, go back to section 1.0, and it makes sense with what they want. And then when you get to 7.0 about the financial, go to the Desire's website, desireusa.org, go to their website, get the most up-to-date information on the incentives available. You really want to make those numbers exactly what is available to them. Now, there's a couple schools of thought when you do this. Many people say include all of the rebates and all of the incentives that are there, and they're certainly valid. Some people won't include it if it's not an available thing. In Illinois, for example, we have a state-run renewable energy incentive program that runs out of funding very quickly, and because it runs out of funding very quickly, it becomes very difficult to get. And so we don't want to tell the customer, yes, this incentive is available, but you most likely won't get it. I would put the numbers in, run it, and then be honest with them. Put in the documentation side of things that these are areas that may or may not exist. So that is something that we may need to do. In Section 7, here's some additional information that you will need to know. Cost and estimated inflation, 2% per year. Estimated electrical price inflation, 3.8% per year. Some of the folks that I deal with at MREA, phenomenal folks. Some folks that I deal with on a professional basis actually like to use a higher estimated electrical inflation rate and a higher estimated inflation overall. I would say make this a 3.8 plus 2.0 for a 5.8% inflation rate. So we really want to have a good value that everybody knows where that number comes from. I would state that historically the 2.0 plus the 3.8 for 5.8 is probably a little low. Over historical trends, some of you will say, well, regionally we're doing less. I can't predict in the crystal ball. I'm going to run with 5.8. I'm going to be a little conservative. If the client goes forward with their renewable energy project and they end up saving more money than you calculated, they're going to be much happier than the rate of return and the cost analysis based on too low of an estimate of increase. We don't know what's going to happen, but those are some numbers that I want you to follow in my class. Expected PV degradation, only a half a percentage per year. Find out what local costs are. As a site assessor, you must not put any sort of data inside of that thing that tells what specific pieces of equipment that you're going to use. But on the other hand, you as a site assessor really need to know what local trends are. Currently, right now in central Illinois, for a residential install, a very rough sketch seems to be shaping up right now in the early part of 2014 as being $4.25 a watt installed. Know what the application fees are. I put those here. And then final estimator, you will need to know what the life expectancies are. Now the life expectancies, and this was the last thing that I want to add, and that is the life expectancy for a system, SYSTEM, is about 25 years. Base the modules and the inverter, 25-year life expectancy. That gets back to very specific pieces of equipment, which we can't really use in our site assessment. So we're in a jam here. I would say you'd be safe basing a system on a 25-year life expectancy and cycle. I think that's legitimate, and I think that's honest. I don't think that would steer anybody wrong. So I think we've got a pretty good handle on the technology today that states that 25 years would be a very good life expectancy for an inverter system. Again, products change. You might get a bad batch, but for our analysis, we're going to go based upon those credentials. So this is what those key parameters are that I need you to follow as we go throughout.